If 3x minus y is equal to 12, what is the value of 8 to the x over 2 to the y? It's not a coincidence that the test makers chose 8 and 2 as the basis here. These are both powers of 2, which means that if we write them in terms of the same base, then our exponent rules can come into play. 8 to the x over 2 to the y is equal to 2 cubed to the x over 2 to the y, which is 2 to the 3x over 2 to the y, since we multiply exponents in this power of a power arrangement. And now that we have the same bases, we can use the quotient property of exponents, which leaves us with 2 to the 3x minus y. And finally, we're told that 3x minus y is equal to 12, so the answer is 2 to the 12th. If x to the a squared over x to the b squared is equal to x to the 16th, x is greater than 1 and a plus b is 2, what is the value of a minus b? We have that x to the a squared over x to the b squared is equal to x to the a squared minus b squared by the quotient property of exponents, and we know from the question that this must equal x to the 16th. Because these expressions have the same base, their exponents must be equal as well, so a squared minus b squared is equal to 16. We now have difference of squares form here, so we can factor the left side to a minus b times a plus b. It says in the question that a plus b is 2, so a minus b must be 8. Which expression is equivalent to 6x to the 8th y squared plus 12x squared y squared? The largest thing in common to both of these terms is 6x squared y squared. So if we factor that out, what remains is x to the 6th plus 2. So the answer is C. Which of the following is equivalent to 9 to the 3/4? The approach I recommend here is to convert all 5 of these expressions to exponential form with the same base. Again, it's not a coincidence that the test makers chose 9 and 3 here. We can write all 5 of these expressions in terms of 3 to some power. First, we have 9 to the 3/4, which is 3 squared to the 3/4. Then multiplying and reducing these exponents gives us 3 to the 3/2. For answer choice A, we can express this as the cube root of 3 squared, or 3 to the 2/3. That's not it. Answer choice B is the fourth root of 3 squared, or 3 to the 1/2. C is also just 3 to the 1/2, but with answer choice D, we get 3 times 3 to the 1/2, or 3 to the first times 3 to the 1/2. We add these exponents to get 3 to the 3/2. The expression 6 times the fifth root of 3 to the 5th x to the 45th times the eighth root of 2 to the 8th x is equivalent to a times x to the b, where a and b are positive constants and x is greater than 1. What is the value of a plus b? Let's start by breaking these radicals up. Since everything is multiplied inside the radicals, we're allowed to do that. Then we can convert each of these radicals into exponential form. Remember that for each fractional exponent, we have the power over the root. Then, simplifying, we're left with 6 times 3 times x to the 9th times 2 times x to the 1/8. The constants multiply to get 36, which gives us our a, and the exponents sum to 73/8, which gives us our b. Messy as this is, 36 plus 73/8 comes out to 45.125, which is our final answer. If a to the b over 4 is equal to 16 for positive integers a and b, what is one possible value of b? This question can throw a lot of people off because it doesn't have a unique solution, and the best way to solve it is simply to guess. B equals 4 is a somewhat obvious choice, but I challenge you to pause the video and find all possible values of b. To do this algebraically, we might raise each side to the 4th power. That gives us a to the b is equal to 16 to the 4th, and to make this as clear as possible, let's express 16 to the 4th in terms of 2 to some power. That would be 2 to the 16th, so this exponent could be split up as 16 and 1, 8 and 2, 4 and 4, 2 and 8, or 1 and 16. So the possible values of b are 1, 2, 4, 8, and 16. The expression x to the negative 2 times y to the 1/2 over x to the 1/3 times y to the negative 1, where x is greater than 1 and y is greater than 1, is equivalent to which of the following? Let's begin by writing this expression without negative exponents. That would be 1 over x squared times y to the 1/2 over x to the 1/3 times 1 over y. If we multiply this complex fraction by x squared over x squared and y over y, then good things happen, and we're left with y times y to the 1/2 over x squared times x to the 1/3, which is d. If I lost you on that last step, then check out my video on fractions to get up to speed there. The function f is defined by the given equation. If g of x is equal to f of x plus 2, which of the following equations defines the function g? I know this notation is going to induce feelings of panic in many of you, so let's start with a little warm-up. F of 3 would be 9 times 4 to the third. If we had f of a plus b, that would be 9 times 4 to the a plus b. So f of x plus 2 just means that we place x plus 2 in the position of x. So that's 9 times 4 to the x plus 2. We then have that g of x is equal to f of x plus 2, which is 9 times 4 to the x plus 2, or 9 times 4 to the x times 4 squared. And finally, that's 144 times 4 to the x, which is b. The function f is defined by f of x is equal to 270 times 0.1 to the x. What is the value of f of 0? This last one is a soft pitch for you guys. I just want to make sure you know what to do with an exponent of 0. Any number raised to the 0 power is 1, so we just have 270 times 1, which is 270. Notice that because of order of operations, that 0 only binds to the 0.1 and not to the 270. If you've learned something here today, then you won't want to miss my next video in this series on linear equations.